Have you ever faced a frustrating issue with your app where requests fail due to token refresh problems? If that's you, you're in the right place. Today, we're diving into how to handle token refresh with OkHttp and Retrofit, especially when dealing with concurrent requests. I understand how annoying it can be when your application throws a 401 error just because multiple requests are trying to refresh the token at the same time. You're definitely not alone in this struggle. It's a common challenge for many developers. Here's the specific situation we're addressing. One user implemented Retrofit with OkHttp and faced issues when multiple requests were made simultaneously. They found that while one request successfully refreshed the token, others failed, leading to a 500 error from the web service. Sound familiar? Let's explore this together. So, what's happening here? When multiple requests are made, the first one refreshes the token, but subsequent requests may attempt to refresh the already refreshed token, causing errors. This can be tricky, but understanding the flow is key to finding a solution. And stick around. I have a great solution at the end that will help you manage token refreshes more effectively, so you won't miss out on any important requests. To address the issue of concurrent requests causing token refresh failures, the user should implement a synchronized mechanism for refreshing the token. This ensures that only one request attempts to refresh the token at a time. The user can achieve this by using a lock or a semaphore. This will prevent multiple requests from trying to refresh the token simultaneously, thus avoiding the 500 error from the web service. Next, the user should modify the Authenticator implementation. They can introduce a Boolean flag to indicate whether a token refresh is in progress. If a refresh is already happening, subsequent requests should wait until it completes. Finally, the user should ensure that once the token is refreshed successfully, all waiting requests are notified to retry with the new token. This can be done using a condition variable or similar mechanism. Did you know? The concept of token-based authentication has been around for quite some time, but it's still one of the trickiest parts of app development. You're not alone in facing these challenges. Now, let's look at the answers provided by other users. This user suggests that the issue arises when multiple requests are sent while the token is being updated, leading to errors. They propose a solution to prevent all requests during the token update using a synchronized object. However, this won't address requests that have already been sent. Instead, they recommend implementing a fallback behavior. This means handling the error from requests made during the token update by rerunning those requests with the newly updated token. Let's take a look at another answer from another user. An alternative solution proposed by a user involves creating a dedicated service for handling token refreshes. This service runs in the background, periodically checking for token validity and refreshing it as needed, thus preventing concurrent requests from failing due to token issues. The user initializes the service by retrieving user credentials from shared preferences and sets up an OK client for making requests. The service continuously runs, executing a task to refresh the token at regular intervals. Here's the pro tip I promised. Always implement a retry mechanism with exponential backoff for your requests. This can help manage load and reduce the chances of hitting errors during token refresh. And there you have it. With these strategies, you should be able to handle token refreshes more smoothly in your application. If you found this helpful, don't forget to subscribe for more tips and keep coding confidently.